Hello students, relax, sit back and listen to our math class. In today's class in set theory, we are going to learn the concept of De Morgan's law for complementation. Okay, let U be the universal set containing finite set A and B. The De Morgan's law of complementation is A union B, the whole complement or the whole dash equal to A dash intersection B dash. Second one, A intersection B the whole dash equal to A dash union B dash. So here union means here intersection, here intersection means vice versa, here union. Now consider this example. Universal set is given, A and B is given. In universal set we have elements from -2, -1, 0 to 10. In A, -1, 1, 3, 5, 7, 9. And in B, -2, 1, 4, 7, 10. Now, first take this left hand side. We are going to prove the first law of complementation. So, first take this left hand side. A union B. The whole complement or whole dash we have to find. So, first find A union B. A union B denotes the combination of this A and B. So, while we are combining the set A and B, we will write this -1, -2, -1, 1, 3, 4, 5, 7, 9 and 10. Next, A union B the whole dash denotes the elements which are not in A union B. So, you have to compare this A union B and this universal set, because in universal set only there will be all the elements, right? So you have to compare these two and you have to write the elements which are not in this A union B. Okay, so -2 is there, -1, 0 not there, so write this 0, 2 is not there, so write this 2, 3 is there, 4, 5, 6 is not there, next 7, 8 is not there. So, A union B the whole dash equal to 0, 2, 6, 8. Next, consider the right hand side. There you have to find the A dash. A dash means you have to write the elements which are not in A but in universal set. -1, 1, 3, 5, 7, 9 are in A. So, except those elements, write all other elements. -2, -1 we won't write, so 1 we won't write, 0 we will write, next 2 we will write, next 3 we won't write, 4, 5, 7, 9, except this 5, 7, 9 you will write all other elements. So 4, 6, 8, 10. 8, 10. Next, B dash. In a similar way, approach this B dash too. So, -1, 0, and then 2, 3, 2, 3, 4 you won't write, 5, 6, 8, 9 and 10. 5, 6, 8, 9 and 10. At last find the intersection of these two. So intersection denotes the elements common to both of those sets. So here the common elements are 0, 2, 6, 8. 0, 2, 6, 8. This is equation 2 and this LHS equation 1. Here this LHS equal to RHS. Because A union B the whole dash is 0 to 6, 8 and here A dash intersection B dash is 0 to 6, 8. This denotes that the first law holds true. That is A union B the whole dash equal to A dash intersection B dash. Okay. Now let us verify the second law. A intersection B the whole dash equal to A dash union B dash. So first find the in LHS find the A intersection B. A intersection B means the elements common to both of these set. So 1 is common and 7 is common. 1 comma 7. A intersection B dash is the elements except this 1 comma 7 in universal set. So write all other elements. Minus 2, minus 1, 0, 2, 3, 4, 5, 6, 8, 9, 10. In right hand side, first find the A dash, the elements which are not in A but in universal set U. Minus 2, 0, 2, 4, 6, 8, 10. Next B dash, minus 1, 0, 2, 3, 5, 6, 8, 9. At last find A dash union B dash. So union means you will combine and write. So minus 2, minus 1, 0, 2, 3, 4, 5, 6, 8, 9, 10. This is your first equation and this is your second equation. Compare these two. Minus 2, minus 1, 0, 2, 3, 4, 5, 6, 8, 9, 10. So both of these are equal. So we can conclude that A intersection B, the whole dash, equal to A dash union B dash. Hence, the second law of De Morgan's law of complementation holds true. Right? Thank you for watching. For more videos related to both school and college maths, kindly subscribe to our channel Curious Maths. Kindly like, share, comment your doubts.